Hey Mac, so this is the design, proposal. You can accept it or not, it's up to you. But, sorry, I'm itching. Okay, so this is just a design proposal. Number one, this is, uh, this design is really meant for, or with this design, I prioritize safety and ease of construction. Installation, it's going to be a little bit more difficult, I think, because if you want something that's really easy to set up, um, it will involve maybe a little bit more slop or play. And I think when you have someone on a second floor, 8 people or more on the second floor, and it's moving all around, you need this to be really, really rigid. And so I decided to do a lot of bolted connections in order to get that rigidity, and also a lot of bracing to get that rigidity, because these people will be 10 feet in the air. It's a lot of torque. If it's not stiff, it's going to be moving around, and I think it'll scare a lot of people. I for one, at least, would be scared, but that's just my opinion. Um, Not saying that aren't other ways of going around it, but this is something I just cooked up with the very limited spare time that I have. It's 3 a.m. even, so I'm just constantly working. Nevertheless, how this is designed, I'll start from the ground up, and explain each component. So, because you have such a large moment arm, and you have so much torque going around. You have 8 people up here. Assuming 300 pounds each, that's 2,400 pounds, and say that they're dancing in the same direction and trying to rock it. It's quite a bit of dynamic force going through the system, and in particular, you have a lot of torque acting around these joints down here, and so you really want to have a very stiff membrane, essentially. So here I first used a lot of 80-20 extrusion. This is used in, I'm sure you know what that is, but if you don't, it's widely used in industrial applications, for tooling, jigs, that kind of thing. It's really stiff. It's pretty easy to set up. So this is all 80-20 aluminum extrusion. I went with this because it's, number one, relative steel. I think it's easier to work with, because this stuff, you can have it machined by 8020.net. I have all the links cut out. You just have to populate a bill of material, or this shopping sheet, and then just order it, and then it'll, for the most part, just bolt up together. And also, with this much, with this kind of structure, it's just going to be really, really heavy with steel, and it's a lot more to lug for the Ford Ranger, coupled with, like, you have the whole thing filled with people. So I thought those benefits, were benefits, and outweighed steel for its complexity of assembly. But anyway, so I have 2 large, very thick beams of aluminum. These are just 80-20 doubled up, something that they sell off the shelf. It's solid structure, and then it would go along the length of the of the chassis on both sides. In fact, I don't have really the wheels here, so I don't know if it impedes or not. I just was lazy about that. But anyway, and I see that there are L brackets here, and assuming that Tom modeled these correctly, what we would do is we would bolt it along the length of the L brackets, and so then you add stiffness to the L brackets, and then you have these columns, 4 columns. Tom had 4, or 6, but I don't think that's actually needed. But 4, and they would be bolted up in a fashion where there's these brackets, these L brackets that they commonly sell on Amazon for a fairly cheap price. Oh, it just disappeared. Actually, that's probably better. So L brackets all around here. They sell 4 for $22 or so. I have to go calculate how many there are, but these would be on every junction. So anyway, you have a 10-foot, or actually 8-foot long pole here, and this is now a hollow structure. This is solid. How it's hollow is these are hollowed out right here in these sections, so it's cheaper material. It's also, a lot of the load is axial, so you don't need that much stiffness, and also most of the load will be going either this way or this way, so it's sufficiently stiff there. But then I have these beams here that are cut at 45 degree and add further stiffness, and you can see on here, so it's self-explanatory up here as well. So it's trying to take into account many of the dynamic loads in all of the axes here. This floor can be taken off, of course, so someone would bolt these up with the L brackets, what's important is that you'd have holes that go all the way through, that kind of thing, and a bolt that passes through. That way it's in double shear, which is the strongest shear for bolts, as opposed to the single shear, of course. So you'd have the same L brackets around here, bolted all the way through, all double shear, and this whole floor can be taken off as well. Potentially you could have just leave these bolted, take this off. Then it is you do have to do a lot of bolting, but just again for safety reasons. Anyway, this whole floor would come apart, and so I'll explain further like this. So it would come off, and it would be like this. So you would basically assemble, and even further, just imagine these guardrails are off. These would be already pre-assembled. There are hinges, so it would go fold this way and that way, and I think it would fit under the Ford Ranger. Of course, I don't have all the dimensions, so that's an assumption. But it would fold that way, and then you could perhaps fold it kind of like a book and stuff it underneath the Ford Ranger as it's parked on the trailer. These guardrails I didn't finish, but the similar kind of thing is the L brackets, that kind of thing, because I'm sure really drunk and high people will be leaning on these. So bolted all this way, and then I just put in 2x4s, but it could be any material here. It really should be, these should be the wrong way, obviously, but yeah, so this should actually be like this. Anyway, so that is the design, and I do have a bill of materials here. The total cost without the L brackets, I didn't factor in all the L brackets, but I do have all the links. It says this doesn't include shipping either. This is all through McMaster-Carr, which is generally a little bit more expensive, and they don't offer the machining services. But with 8020.net, which is the producer for these kind of things, you can actually insert the lengths and everything, which I have noted. And if you want, I can create a bill of materials if you do like this design, and then you can just order it straight up. But basically, you have these slotted materials here, that kind of thing. We're actually using like a 40 series, but for all intents and purposes, 10 is good. So here you can add length of like a bajillion inches. And you can add machining services, kind of miter cuts. This is what would be necessary for these braces here, but it's all essentially plug and play. Where I thought with the steel design, with all the welding, there's a lot of warpage that can occur, and I just think it would be a major bitch. And without proper jigging and stuff like that, I think it'd be kind of a pain in the ass to make sure that, for instance, you weld this down here. This you have such a long column here that for it to just move out of whack and not be aligned with all these others, it's it's a definite, not a like slight possibility, but it definitely will be out of whack, and people, Mark or whoever, will be fighting this thing left and right, and so I just think with the 80/20, it's machined. Anyway, so that's that. So hopefully this wasn't too rambly. Talk to you soon.